Exactly 1 month ago, I made this adapter here, and it's called a Ryobalt 24-volt adapter, in which I can use my Kobalt 24-volt battery, and I can put it in here so that I can have a 24-volt output at a Ryobi terminal up here, and that way I can use a Kobalt 24-volt battery for a Ryobi 18-volt tool. And I've been using this adapter with my Ryobi tools for 1 month, and in this video I'm doing a follow-up and talk about how it turns out, how it works out with my Ryobi tools. And then I'm going to do a couple tests to compare between the Ryobalt 24-volt and the original Ryobi 18-volt on an original Ryobi tool. And then I'm going to also do a test to compare between a regular Ryobi tool but runs on 24-volt compared to the actual Kobalt tools to see which one will win. First of all, let me answer some of the questions you guys asked about the last build. The video was 24 minutes long, so I didn't want to squeeze any more information into it. So here we go. The first question is from Brad Habit. He asked, why did you sacrifice a lithium ion when you had the case from a nickel cadmium? Well, Brad, I actually started with a Ryobi nickel cadmium case, and here it is. I spent half a day trying to design, make, and then videotape the whole process, and then I finally realized there was a huge problem. So I was intending to use the top portion of the battery and discard the bottom portion of the plastic cover, and I made the wires to terminals, secure the connections together, and I made a wooden shim to install the metal clip. This shim used to be on here, and then I tried it on my Ryobi tool just to realize that it does not lock in. There is a latch, a couple of latches, but it stays on the bottom cover, not the top cover. So now this is not loose, but it's not secure because there's gonna be a lot of weight on the bottom here, and you know, this is heavy, and this might come loose when I'm using it, you know, without the latches to lock it into the tool. And that means I have to use the bottom cover in order to use these latches. But the bottom cover of a nickel cadmium battery is way too thick. After adding the Kobalt battery on the bottom here, after install it, it'll be too big and too clumsy. So that's why I abandoned this project and started all over again. And this time I use a thinner lithium ion battery case because it's thinner. It will not be too bulky after I install my Kobalt battery in here. The second question is from Lupilo. So you using a 24-volt battery on a 18-volt drill will kill the drill with time, don't you think? Well, yes and no. Yes, over time anything will kill any drill, especially when you use it a lot. It doesn't matter if you overvolt it or not. And no, this overvoltage has not killed my drill, at least for the last month. Not only did I use it for my drill, I also use it with a lot of other Ryobi tools I have, and so far I have not got any problem at all. So let me explain. This is the original Ryobi 4Ah 18-volt battery. It's labeled 18-volt, but when it's fully charged, it's actually 21 volts. So there are 5 18650 cells in here in series, actually 10, but they put it in parallel. So 5 times 4.2 volts per cell, that's exactly 21 volts. And that means Ryobi has to design the motor and electronics to be comfortable to run at least 21 volts, right? That's at least when this battery is 100% full. Of course, it's only 21 volts for a brief period of time, and then the voltage will go down. But at least it has to be comfortable at 21 volts, right? That's called redundancy. This battery is 24 volts, right? It's ready at 24 volts because it has 6 cells in here in series, and at full charge it's 25.2 volts. But because it only stays at 25.2 volts for a small amount of time, most of the time it's below 25.2, and most of the time it runs at nominal voltage, because when it runs under load, this voltage will be reduced, right? It won't stay at 25.2 volts all the time. And the nominal voltage for this is 3.7 volts for each cell times 6. We got 22.2 volts. So now if you compare 22.2 volts versus 21 volts, now it becomes less severe, right? It's only a little bit over 1 volt over voltage. And that's why I haven't got any problem so far with all the Ryobalt tools that I use with the 24 volt battery. And in fact, if you follow my channel, you have probably seen I overvolted everything. Electric bike, electric scooter, electric go-kart, anything that I have, I overvolted them. Let me show you this Ryobalt battery running on some of my tools. This is the 18 gauge cutter. Works just fine. This one is the Ryobalt inflator. It works just fine on this inflator, and I can feel the output is a lot more. There is a lot more pressure, air pressure coming out this nozzle when I use this battery. This one here is the high pressure inflator, and this is completely electronic control. So put it in and turn it on. Everything here is electronically controlled, but it still works fine with 24 volt. And okay, let's try the low pressure inflator. Okay, on this side there's a fan here on this side. Okay, let's start. You can see here it works just fine with the 24 volt battery, and again I can feel a lot of air pressure coming out, a lot more compared to the original Ryobalt 18 volt battery. I've got a long bolt here, and I'm going to put this into the wood, and I'm going to compare the output difference between a 24 volt and an original Ryobalt 18 volt battery to see if a higher voltage on a Ryobalt tool will result in a higher output. My second test is to compare the output between a Ryobalt with a Kobalt 24 volt battery and a Kobalt 24 volt tool on a original Kobalt 24 volt battery, and also the newest XTR impact driver from Kobalt. First up is the Ryobalt impact driver on a 4 amp hour 18 volt Ryobalt battery. Next is the Ryobalt impact driver on the Kobalt 24 volt battery. So on this test we got the Ryobalt tool on the Ryobalt 18 volt battery for the first clip. For the second clip we got the Ryobalt tool on the Kobalt 24 volt battery. So for this test, you can see this area is much bigger than this area. So for this, it takes much longer to complete compared to this. So for the Ryobi original 18-volt battery, it does take much longer to complete compared to the Ryobi 2 on a 24-volt battery. So for the 18-volt battery, it takes exactly 3 seconds. For the 24-volt Kobalt battery on the Ryobi 2, 2.1 seconds. So this is about 30% faster compared to this. So for this test, I can definitively say that the Ryobi 2 on a 24-volt battery is much faster, in this case 30% faster than the original 18-volt battery on the same tool. So the first test is a Ryobi impact driver on a Kobalt 24-volt tool. Model number of this Ryobi is P237 impact driver. Alright, here we go. Next one is the first generation Kobalt impact driver with a 4 amp hour battery, and it's fully charged. Next is the Kobalt XTR impact driver. So next I have a beluga whale, the Kobalt XTR half-inch impact driver. I know it's not a fair test because it's not the same class, but I'm curious to see what the output of this is, and I have it here. Might as well just go for it. Well, this thing is so strong. The impact action doesn't happen until the bolt is almost in there. Let me show you my video editor. This is how I can determine the amount of time it takes for each test. So the first clip is the Ryobalt battery on the Ryobi 2. The second clip is the first generation Kobalt impact driver. The third clip is the XTR impact driver, and the last clip is the XTR impact range, the beluga whale. So on each clip, it's got the black part here from here to here. So this is where it starts and that's where it stops. And I can measure accurately how much time it takes from here to here. So for the first test, it takes 2.2 seconds. For the second test, it takes 2.6 seconds. For the first generation Kobalt, third test takes about 1.5 seconds. You can see this area here is much smaller than this and that. And for the last test, it takes 1.7 seconds. So from here to here, 1.7 seconds for the beluga whale. So as you can see, the Ryobi 2, the 24-volt Ryobalt battery, it actually outperformed the first generation Kobalt impact driver. So the champion here is the Kobalt XTR impact driver. It is 40% faster than the first gen impact driver, and it is 25% faster than the Ryobalt tool, and it's even faster than the XTR impact range. I think the reason why the XTR impact driver is faster than the XTR impact range, that's because the XTR impact driver, it has 3400 RPM maximum speed, whereas the XTR impact range only has 1900 RPM maximum speed. It does have a lot more torque, but the speed is a bit slower. But that's for this test only. If I use a bigger bolt and in an application that requires much more torque, there is no way the XTR impact driver can beat the impact range. And the evidence is here. You can see clearly. Look at the sound wave. It's almost a complete rectangle. Okay, whereas on the impact range, the area is smaller. That's because there's much less noise on the impact range. It makes less noise, and therefore it doesn't work as hard as the impact driver. You see here, it works so hard to put the bolt in the piece of wood, whereas the impact range has no problem at all. And until the end, almost until the end, this is where the impact action starts. And you can see from the beginning all the way almost to the end, there was no impact action almost until it reached almost to the end, and it has some impact action. And that's it for now, folks. Next video, I'm gonna do a full review of this beluga whale, the Kobalt half-inch impact range. So stay tuned, and I will see you next time.